Maria Gomez. I'm a tech principal in ThoughtWorks here in Barcelona. I have just under 10 years of experience in the tech industry. Most of it, or at least a bit more than half, have been in ThoughtWorks. I have traveled quite a bit with ThoughtWorks. I work in the UK, in the US, in Ecuador, in India, and obviously in Spain. And I have played different roles, and sometimes being an architect, and sometimes I've been an agile coach. But I guess all the time I've been a developer. And most of all, I'm a woman. I'm a woman technologist. And I'm passionate about fixing the gender issues that you can see in our industry. And that's why I want to take a few minutes at the beginning of the talk to address something that happened yesterday in this conference. So during the welcoming I guess talk at the beginning, there were certain jokes that were shown that were not really appropriate for a professional setting like this one, right? Actually, I will argue that they are not appropriate for any kind of setting. And this is not okay. This is not okay because we are not showing showing respect to certain parts of this community. And I talked to the organizers, and they made a mistake, which we are all guilty of making mistakes, but we are all responsible for taking the appropriate actions to those mistakes. The organizers are actually taking those actions and making sure that people understand that this is not an acceptable behavior in a conference like this, that they really care about diversity, they really care about these issues in the industry. So I think that's great. I think that people acknowledge things and then they take actions to solve these issues. But things like this are the reason why 66% of women feel excluded in social and networking events like conference. That's why you don't see that many female representation in conferences. Why you don't see them in events or meetup? It's because certain attitudes of other people make us feel unsafe. They don't make us feel welcome, and also we feel uneasy and uncomfortable with certain behaviors. And they also contribute to something that is called the imposter syndrome. The imposter syndrome is something that sadly happens to a lot of people that work or live within a minority. So that not only happen with women, that happen with a lot of people in our society. This makes you think like you don't belong, like you are less worthy of being there, and it prevents you from getting the recognition and sometimes even the pay that you deserve for doing something that your male colleague will get much more money, they will get much more recognition, a better career path, and you're doing exactly the same thing that that person. This is a figure from the US, from Silicon Valley. I couldn't find a figure for Spain, but in Silicon Valley or in the US, only 25% of the workforce in technology are women. And jokes like this normalize and accept and make us accept that this behavior is not okay, and by allowing that to be the norm and by allowing that to happen, we are normalizing and making this type of jokes acceptable. And that doesn't help increase the diversity that industry needs. Because diverse teams and diverse companies will produce much better products, will serve their customers in a much better way, because it will have a better representation of those customers. I guess what I want to say here is that I felt that was inappropriate. I didn't feel comfortable with those jokes, so I went to the organizers and gave them feedback, and the response was really good. So I will urge you to do the same if you also felt that this wasn't appropriate, and not only here, in any aspect of society, in your company, in other events. If you see things like this, please speak up, because us as a community have the power to make these changes a reality, and we should be empowered and not be afraid to speak up and to solve these issues. So, after this, I'm gonna start again, and I'm gonna, thank you. Thank you. So, sorry, just gonna take some water. So, let me start again with our topic. This is observable microservices. So I'm going to talk about observability and how we can make our microservices easier to observe. To do that, I'll use some examples of challenges that I have faced in a few projects that I've been to in the last 2 years, something like that. And I hope that after this, you will leave with a few things that you can try and you can test in your project or in your companies. So, to start in a lighter note, let me tell you about a trip that I did last year. So last year I went to New Zealand, which is an amazing place. It's awesome. It's one of the best places on Earth. Definitely recommend you to go there. And my boyfriend and I spent like 3 weeks traveling around the 2 islands. So this is a picture of one of the places that we visit. This is the Tongariro National Park that is in the North Island. And I don't know if you know this, but New Zealand is where The Lord of the Rings, so LOTR, and The Hobbit were filmed. And this national park is where Mordor is located. So we actually, and that was the view from our hotel room, so we actually spent a night in Mordor, which was really cool. So, you know, the story goes that Sam and Frodo go to Mordor, and they had to destroy this ring, and they face a few challenges over there. So they have, you know, different types of orcs that want to kill them. Gollum, who wants to steal the ring from them. Spider that wants to eat them. And then you have Sauron that obviously wants the ring because he wants to conquer the wall and be all evil and stuff. So, you know, all in all, it's a pretty hostile environment, right? Mordor is really hostile for Sam and Frodo. And there is another environment that is also really hostile for us, and that's a production environment, right? We have we have bugs, we have security breaches, we have servers that will get overloads or node that will drop, and things that will happen that just we weren't expected or that we didn't see anywhere else. So, you know, in the good old days of the monolith, we could get by using a more traditional approach to monitoring and to debugging and to going into certain boxes. But when we start getting into the distributed land of microservices, then those problems get multiplied by tens or hundreds. So what might have worked for a monolith doesn't work in a microservice or a distributed architecture. So we need to think of new ideas, and we need to apply new patterns to make sure that we can safely maintain a distributed system like this one in production. And one of the most important things is to make sure that those services are playing with us and they are actually telling us what they see and how we can help them. So I guess you all know this book. Sam Newman wrote it like a couple of years ago, kind of describe microservices and how you can go about building them. And one of the things that it does is that it lists what some things are the principles of microservices, right? So, you know, they should be modeled around business concepts. They should follow a culture of automation. They should hide internal implementation details, so the whole thing of like standardized on integration but not on implementation. By decentralizing all the things, we can achieve, you know, this distribution or the distributed system that we want. They should be deployed independently. Isolated failure, you know, if we have a microservice failing, there should be some mechanism that will isolate the failure and the rest of the system should still work. And last but not least is that they should be highly observable. So obviously that's the last one. That's the one that we are going to focus on. And I think that's the one that we are still struggling to apply, because it's really difficult, right? It's not an easy thing, and it depends of a lot of things. So to me, a microservice is observable if it's easy to discover, so we know where all the instances of the service are. It gives us comprehensive, but at the same time concise and useful logs. Expose metrics that allow us to monitor their behavior or its behavior successfully, and make the debugging process less painful. So I'm gonna go through each of them and explain why they are important. So we're gonna start from the top. That's discovery, because we are still in New Zealand. This is another picture of my trip. This is a steampunk museum in Oamaru. This is a city in the South Island where there are also penguins. So yeah, they have this crazy, really, really cool museum with a lot of these steampunks artifacts. Now, having a centralized way of managing, all the instances of a microservice will be one of the building blocks for what's coming next. It will allow us to set up, centralized logging or centralized monitoring dashboards and all of that stuff in an easier way. Services, just to explain a bit what we meant by that. Services are normally they call each other. They will, if they have a one-on-one relationship, they might know where this other service lives. If that service that never changes the IP, they might not need to even have that as a parameter. So life will be easier. But when you start scaling microservices up, which is one of the reasons why you would like to use microservices in the first place, you start getting certain problems of how can you make all of these services discover each other. So it's a very standard pattern that I hope a lot of you know, which is the service registry pattern. That means that you just basically have a service registry where your services will, or the instances of a service will register to. In this case, which is the server-side registry, your service A will call router or something, kind of a gateway in the middle that will call the service registry. I will say, hey, I need to call service A, and the service registry will say, oh, I have these 3 instances for service A. So the router will choose, and it will do some load balancing or whatever to choose which one of the instances to call. So this is server-side discovery. There's also client-side discovery, which kind of makes the service call directly the service registry and just decide which one to call and do the load balancing by itself. A lot of the frameworks like Spring Boot and things like that will allow you to do client-side discovery almost out of the box. So it doesn't matter what you use, but this now allows you to start making your services available, not just to other services to call, but to other tools that might need to use them later on. An implementation of service registry can be as easy as a static file that is highly available, or you can go to more complicated stuff like distributed key value pair, like KTC-D, or going for more of like a distributed configuration tool like Console. So in conclusion, this discoverability is an important building block in which, because it will help us with the rest of the tooling, like for instance, logging, which is the next thing that we are going to talk about. And the picture for logging is this place in the North Island, in New Zealand. Everything is in New Zealand. So this is the North Island, and New Zealand has all of these super green, landscapes. It's like one of the greenest places that I've seen. So this is one of those places, and you see it's beautiful. So talking about logging, logging is important. It will help you understand what's going on, and also it will help you debug any issues. You will need to know what has happened. You know, if you have just one service or a monolith, you could just go and request the logs of that box and start going through them, and use your text editor of choice to find any issues or anything like that. But when you have multiple things, multiple microservices or different shapes and sizes, that can be a bit difficult. So using something like an aggregator that can help you visualize logs in a centralized place, like the ELK stack, which is really common, will definitely help you. So now you have Kibana that will allow you to do search. It will allow you to not just search in one single instance, but in multiple. So you can start like adding criteria and all that stuff. So it's really useful. But the problem is still, or the challenge still resides of what should you log? What is important enough that should keep a record, that you should keep a record of? Because logs can be really messy. They can contain a lot of noise because you can log everything if you want, but you will end up with like problems with your disk space, because the more that you log, the more space you will need to store those logs. And also, it can be searches are much more difficult, and finding information might be much more time consuming and difficult. So deciding what to log is a really difficult and complex process to go through. Your teams should do this and should make sure that you adapt as your architecture also evolves. So I'm going to give you an example of projects where we have this kind of challenge, right? So like a year ago, I was on a project in the US with a credit card provider. They have more than 20 million accounts, and we partnered with them to build a new platform to manage their core business processes. So basically, we built them a new bank. Well, we, with them, built a new bank. This platform was made of different domains. Each of them will represent a business offering, for example, payments or applications or statements, something like that, right? And they were a set of independent microservices. So to get a statement out, you might need 2 or 3 microservices. They communicate to each other through events. So there was an event bus in there, and they follow 2 very trendy patterns, which are CQRS and event sourcing, obviously. So, this is a really complex architecture because you have a lot of things going on. There's not just the events that one of the domains will publish and other domains will subscribe to. There's also events going from the right side to the read side of a single service. We were not. One of our principles was that there were no direct communication between any of these parties. So a domain couldn't call another domain. The right side couldn't directly update the read side. So that means that there was a lot of things going on, a lot of events and a lot of things that we could log. So we'll end up with logs that will contain a lot of stuff, and it was really difficult to understand what was important. So we did a lot of process on what are the things that are really important to us as a business, what are the things that for an operational perspective you will need to know in case there was a problem, and answering questions like that will start to help you to just pick the minimum or close to the minimum that you need to successfully maintain a service in production. Obviously, this is an iterative process, and you will learn as you go along. So we didn't get it right the first time. We had to tweak it a few times. One of the lessons that we learned was that naming was super, super important for this. So you know how when we are coding, we talk about in clean code, you talk about how naming your classes in a way that they express intent. But the things that you log should also follow the same pattern. So in our case, we had to log some of the events that we were publishing, so we had to make sure that those events will have a name that will also show the intent, right? Because otherwise you start creating silos, you start making the codes and the logs difficult to understand by people that are others to the ones who actually wrote the code. Another thing that we found is that the consistency among those microservices was also really important. So standardize also on the way that you are logging, so all your services have a consistent way of logging, and they follow kind of the same format. Then they can use any implementation or any library that you want to log, but that they follow certain patterns. So it's easier for people who are not familiar with the code to understand what's going on. So yeah, the same thing, standardize on integration, not on implementation. In this case, it also applies here. Our third item is monitoring. And the picture that I chose for this is near Mount Cook. Mount Cook is one of the most famous mountains in New Zealand. It has glaciers, and it's also an area where they call it a clear sky area. So it's one of the places on Earth where you can actually see the sky at night, like the clearer, or one of the clearest skies. We actually couldn't see it because it's also an area where the weather changes a lot. So it might be sunny in the morning, and it will be cloudy and stormy in the afternoon or in the night. So anyway, but it was a beautiful place. So going back to monitoring, why monitoring is important? Well, I don't think I need to say this, but you want to understand what's going on, and you want to be able to see it close to real time, or as close to real time as you can. So with that many pieces moving, with that many microservices and systems integrating with the services integrating with each other, sometimes it's really difficult to have, you again are going to have a lot of things to look at. So making sure that you have some kind of centralized dashboard that gives you a snapshot of what you need, and that you put it in a place visible by all your team is really important. Even if you're not doing production support, it's really important to have this, because it will also encourage a culture of owning the code, not just when you're building it, but also when that code is in production and when those systems and services are in production. The same thing happens with monitoring as it happened with logs. There are so many things that you can monitor that choosing what is enough or what is good for you is really, really important. So I'm going to give you another example. It's another project. This is for an online marketplace. They're one of the biggest marketplaces in Europe. They have more than 10 million users per month. They have more than 10 million articles on stock, basically. We partner with them to add new products, to evolve their architecture, and to improve the overall user experience. So in terms of technology, they follow a much more diverse approach. So they have different patterns introduced in different areas of the business. For example, in our team, we have a service that reads from a Kafka stream. It runs some business logic, stores some information on a database, so it can be exposed to different channels, and it also send the results of that business logic into another data stream, so it can be consumed by other consumers of that pipeline. So we had to decide how we were going to monitor that service. The first thing that we did was, we need to know if this service is running first of all. So we follow the standard pattern of creating a health check endpoint that will just give us the heartbeat of the service. So basically, you expose that endpoint, and if you can reach that endpoint, then that means that your service is healthy. The next thing that we say was like, the service can be up, but maybe the database is down and we don't know. So we also add to that health checking point a simple query that was not going to affect the performance of the database to just make sure that it could connect to the database. And that same pattern was followed with the 2 data streams. So you could actually check that you could access any dependencies that that service needed in order to function. So now we have health endpoint that is actually telling all of that information. So we can have our dashboard requesting this or calling this endpoint on a cadence, on regular intervals, and that will allow us to see if our database goes down. Our dashboard can also alert us of that. And the same thing happens with metrics. It's really easy with any of the modern frameworks that we use to build microservice to have a metric endpoint that came out of the box, or otherwise it's really, really simple to implement. So you will have things that go from like memory usage to response times to medians and percentiles and the type of responses that you are the type of responses that the requests are getting. So there's a lot of information. So sure, you wanted to be able to show that information in the dashboard, but you need to be pragmatic in terms of what you want to show, because showing too much will also makes you feel a bit lost. Because there will be so many things, your dashboard will be really, really big. So, for example, in our case, we really wanted to know the number of 500 errors that we were exposing, and that could give us a good way of start identifying patterns. A 500 error here and there, it might not be that big of an issue, but it can highlight some underlying problems that you might want to look at. We also wanted to know how the system reacts to certain changes. So if we create a new functionality, will that functionality or a new business logic in one of the flows? So will that functionality affect the response time of our service and things like that? And if you want to go even farther from that, you have to look away from individual services. So we were looking at getting metrics from the operations of individual services, and we can go one level higher and say, okay, my services are actually not providing functionality on their own. They you combine multiple services, and that will give you a functionality, right? So the concept of synthetic or semantic monitoring is the one that tells you that you can actually monitor flows and that you should be monitoring flows. So you have already those flows that are called user journey test, application level test, or whatever you call them. You normally have them being run against your staging or your testing environment, right? So you could actually get a subset of those that are representative enough and run them in production, run them against the production service. And that can give you another data point that will allow you to not just monitor individual services, but monitor the overall functionality of your system. And obviously that comes with some complications, because you might need to create certain test accounts in production that won't fulfill orders, for example, things like that. But you start getting a better picture on your dashboard of things that really matter to you and to your business. You can use a lot of tools to create dashboards. I had used Prometheus before. In the current project, we are using Datadog for some things. We are still using Dashing for a small dashboard that we have. So there's a lot of tools that are paid, open source, that you can use to get something up and running really quickly. But sometimes monitoring dashboards are not enough. You want something that can alert you when something goes wrong. So those are alerts. They are also difficult to get right the first time because there are so many things that you can get an alert on, and defining that baseline can be quite difficult. So this concept of smart alerts. So let me tell you about smart alerts with an example. So imagine we have a broker, so we have a queue, and there are messages that are going through that queue. And then for some reason, the consumer is not consuming them fast enough, or it's not consuming them fast, right? So in itself, that might not give you an error, that might not trigger anything, but it might be that there is some problem in there. So we start, when we have this problem, we start like logging certain data points, like what are the number of messages that we're processing here, or we're sending in here, versus the number of of messages that were processed by the consumer. So we were like getting all of that data and starting to create alerts that will combine a few of those data points. So now we can have alerts that say, hey, your queue is getting all of these messages, but it's not something that happens, on 10 seconds. It's something that's been happening for the last 5 minutes. Because you can have a spike on the number of messages, and that's fine, and your queues will be able to handle that. But if a period of time has passed and your queue and your consumer is still not processing those messages, that can be an indication that something is wrong. Alerts, either smart or traditional alerts, can also be set up by normally the same monitoring tool that you're using will have a way to doing alerts. Those alerts can obviously give you an indication that something is wrong, and you can fix it. But it can also give you a warning of like, hey, there's nothing wrong, but your microservice is starting to get out of resources, so you might need to scale that microservice up. So this is also really, really important for maintaining a healthy environment. If you're using things like Amazon, they actually have an auto-scaling mechanism, so you can set up what are your baselines, and it can do the auto-scaling for you. Now, where to go next? If you are doing all of this stuff, I guess the next thing for you is to start looking at more dynamic way of monitoring. And that goes in the in the intersection between application performance management and machine learning. So these are things that App Dynamics and Datadog, a lot of these companies are starting to, well, not starting, they've been doing it for like a year or two at least. But they offer all of these things now, and companies are starting to implement them and use them. These are tools that can learn from your services, and they can adapt all of those monitoring and alerting tools based on those learnings. So for example, the way we create baselines for our alerts is really focused on mediums, and it's kind of one-dimensional. Whereas in a distributed service, you want something that is a bit more multi-dimensional. These tools allow you to get this APM learning how your system behaves and how your services behave, and choose a baseline that is dynamic. So you can get a better alerts and much more close to how your system behaves as a whole. So to summarize, make sure that you invest on a clear and easy way to use a dashboard where all the important metrics for you and your business in terms of operations and sometimes also KPIs and show and create alerts that are actually useful and that they will give you the good indication that something, or the right indication that something needs to be fixed. Because at the end of the day, you want an alert to tell you that something needs to be fixed now. And last but not least, is debugging. And this is one of the best pictures that I have, actually. This in a beach in the South Island also. This beach has these kind of boulders. They are like these spheres of rock, and because of the erosion, some of them will they just break down. So I think this was actually a really nice metaphor of when your service breaks and you need to go inside to see what happened. With a distributed system, you might have a request that goes through multiple services, and it might even go through third-party applications or other things. So having a way to trace that request is really important. So in this example, that was from the bug platform that we were building. We noticed that some of these requests will go through different domains and different applications or just different services. So we attach what we call a trace ID. Other people just call it correlation ID. So it doesn't really matter how you call it. It's just a unique identifier that gets attached to that request the first time it enters the system, and then it follows that request all the way until it finished. So what that gives you is that when you go to your log aggregator and you need to review an error, you might have an exception, and that section in the text stack will contain that trace ID. That's where the trace ID of the request that was run and that was faulty. So the trace ID will allow you to then go to Kibana or whatever log aggregator they're using and kind of filter and show only the logs for that trace ID. So now you might have a better picture of what has happened. What we found is, in our case, because we were not just distributed, but we were also asynchronous. Everything was asynchronous. We found that in order to find the actual origin of that request and understand what it went through, we had to go through all of this tedious and super time-consuming process. And also, we're starting to get specialized people that were really good at doing this, whereas other people didn't want to have anything to do with debugging and kind of going through all of these logs. So we started to create silos. And silos are not good because you want the information to be spread as much as possible and the knowledge to be shared with your team. So whereas having a trace ID and a log aggregator and filter that out is probably more than enough for most of the systems that we build. Sometimes with extra and more asynchronous system, you might need to use something extra. And that's when things like distributed tracing tools can help you. So this is a screenshot from Zipkin. So Zipkin is, I think it's one of the most famous distributed tracing tools. Datadog, which I mentioned before, also has one of these. So it's not the only one. But what it allows you is to gives you picture of what that request has gone through just by using that trace ID. By using the notion of trace ID. So now, even if your system is asynchronous, you can have at least a better way to visualize how the request went, and that will help you making debugging less painful. You will still need to debug, and you will still need to understand what has happened, but at least this can help you in that process. So we have reached the end of this talk. So yeah, to summarize, I think to me the most important thing is that making microservices observable is not an easy task, like anything that has to do with microservices and distributed systems. Make sure that you think about these 4 things and how you can make your services more prepared to be effectively run and maintained in production. And I'd like to end by saying that you found this talk interesting and want to work in a place where we face these type of challenges almost every day. You can come and talk to us, to me. We are hiring, or you can email email me directly or email our super easy to remember hola@thoughtworks.com. Thank you.